In this video, I will explain you equivalence class. To understand this concept, we have to go through with this example. Show that relation R in the Z, the set of integers given by R equal to a comma b such that 2 divides a minus b is an equivalence relation. Now we'll prove equivalence relation as we were doing it in first video. Now see solution. Reflexive. R is reflexive as 2 divides a minus a. As you know that a minus a is 0 and 2 can divide 0. For every a belong to integer z implies that a comma a will belong to R. Similarly, symmetric. R is symmetric as AB belong to R implies that 2 divides A minus B and 2 divides B minus A implies that B comma A will belong to R. So this means R is symmetric also. Now see transitive. If A comma B belong to R, this is equation 1, and B comma C belong to R, equation number 2. The first equation implies that A minus B divisible by 2, and second equation implies that 2 divides B minus C. Again, if I add both A minus B and B minus C, I will get A minus C, which is also divisible by 2. This shows that R is transitive. Now we have proved that R A B 2 divides A minus B is reflexive, symmetric and transitive. So this shows that R is an equivalence relation in Z. Here we observed that all even integers are related to 0 as 0 comma plus minus 2, 0 comma plus minus 4, comma 0 comma plus minus 6, etc. lies in R, as 0 minus 2 or 0 plus 2 will definitely divisible by 2. Similarly, 0 plus 4 or 0 minus 4 will also divisible by 2. And no odd integer is related to 0, as 0 comma plus minus 1, 0 comma plus minus 3 does not belong to R. As you can see here, 0 minus 1 is equal to minus 1 is not divisible by 2. Similarly, all odd integers are related to 1 and no even integer is related to 1. Therefore, the set E even integer and O odd integers satisfying following condition. All elements of E are related to each other. Similarly, zeros elements related to each other. No element of E is related to any element of O and vice versa. Third, E and O are disjoint and Z is equals to E union O. If you consider all even integers and all odd integers, the union of that will give you set of integers Z. The subset E is called equivalence class containing 0 and is denoted by 0 and in this kind of bracket, square bracket. Similarly, O is containing 1 and is denoted by 1 in square bracket. Here you must try to understand that why we are taking 0 as equivalence class. This equivalence class, why we are taking this? Because of this relation. This 0 comma minus 2 plus minus 2 and 0 comma plus minus 4 and 0 comma plus minus 6 lie in R. As you can see that this 0 plus 2 will give you 2, that is divisible by 2. Similarly 0 plus 4 will always give you a number which is divisible by 2. That's why we are saying this 0 as equivalence class. Similarly, this happens for 1. According to the concept we have studied above, here 1 will be related to 3, 1 can related to 5, 1 can be related to 7. And why it is related to these numbers, these odd numbers? Because when you subtract 3 minus 1, you will be getting 2, a number divisible by 2. Similarly, 5 minus 1 will give you 4, and which is divisible by 2. That's why these numbers, these ordered pair, are related to or belong to R. So we call this one as equivalence class. Thank you.